Good evening, everybody. Welcome and thank you for coming tonight. My name's Bowman Bradley. I'm representing something called the IWA Sustainable Propulsion Group. Most people will be aware that engines using petrol, diesel, other forms of similar materials are becoming increasingly unpopular, and there is a intent in the UK to stop road vehicles being driven by such things in the not too distant future. Now, up to now, the inland waterways have escaped much of that, and nobody has taken a great deal of notice of us. But I can't honestly think that that is going to go on forever. So we formed the Inland Waterways Association Sustainable Propulsion Group some months ago now, before Christmas, to look at what might be possible in the inland waterways if we didn't want to use petrol or diesel or any of that type of material. We gave ourselves a couple of constraints in what we're doing. Constraint one was that we were largely going to look at narrowboats, although much of what we are doing would also apply to broad beams, mainly because narrowboats tend to be the same size, same shape. There's an awful lot of them on the inland waterways, but a lot of what we are going to be talking about, some of what we're talking about anyway, could be applicable to other boats as well. The other thing we said at the beginning was we would try and stay with technologies that were either available or very close to be available. We weren't going to particularly look at blue skies thinking. So those are our basic rules. There's the group. List of names. I'm sure some people there will know some people on that list. There are three of us here tonight. I'm doing the presentation. Malcolm Bridge and Rupert Smedley will be around to help me answer questions later. And actually, when you look at the three of us, it's quite interesting. We all own boats, as no great surprise. Malcolm owns an electric boat, so that is of great interest to us, certainly, and hopefully other people. Rupert has got a very, very old and traditional boat, an ex-working boat with a very interesting engine in it. And I've got a boringly normal, modern, narrow boat, 57 feet long, with a ubiquitous 4-cylinder, 2-litre diesel engine in it. So I think we've got quite a few of the bases covered in terms of the sort of boats that we are, we know a little about anyway. So what is our objectives? Well, that was objective number one, and that's to monitor and encourage the development of technologies to identify a sustainable model for inland waterways boating. You can read that as well as I can. What we mainly wanted to do was to develop a vision of how the inland waterways might become sustainable in the future. So what we're doing is we're not trying to design a boat, we're not trying to say how it should be done, but we're trying to put together a vision so that people that know a lot more about bits of it than we do can say, I can contribute to that bit, or maybe even to say, that bit's totally wrong, you should really be looking at it this way. So we've tried to develop a vision, and what I'm going to talk about tonight is what that vision is currently at the moment. We've also got to look at how we can mitigate the environmental impact of the existing fleet, because that's going to be with us for quite a while. And finally, we want to encourage the development of more sustainable boating with publicity education activities. So that's really what we are trying to do. Let's talk for a few minutes about the stakeholders. There's a list of stakeholders that we've identified. These are people that have an interest in the inland waterways. There are also people who, quite honestly, if we're going to have a large change in the way in which we propel boats away from petrol and diesel, mainly diesel, all those people will have an interest in what we're doing. And I think most of those people will have to make some investment in the future if they are going to cope with a future different type of inland waterway propulsion. Some of the investments will be large. People like boat builders, navigation authorities, hire companies, they're going to have quite big investments. Marinas probably. Other people, perhaps smaller, but they're all going to have to do something if we change. And I think, to be honest, we are going to change. And of course, two very important stakeholders there are legislators, who no doubt will have some influence on what we do, and of course the society at large, because all the issues we know around global warming. So let's go and have a look at sustainable propulsion. What does that mean? Well, I'm going to take a few minutes, largely because I quite like it, looking at how we've propelled narrowboats since the canals started in the 1700s. Well, that's how we started, 1 horsepower. And there have been those people who said, well, there's the answer to your problem. We'll go back to that. Probably it's not the right answer, but never mind, that's how we started. The next development was, I think I'm right in saying, was that thing. That is President. It's still around today. It's one of a fleet of Fellows Morton and Clayton steam-powered narrowboats that was built in the early 1900s, I think. Yeah, let's get that right. And that boat is still around. It's based at the Dudley Museum. There's probably people listening to this who know a great deal more about it than I do. But that was probably one of the early attempts to put an engine in a boat. Now there it is. Not many people will have seen that photograph. That is President at the Queen's Jubilee pageant down the Thames in, I think it was 2012, was it not? That was taken by a friend of mine who was in the pageant behind him. And interestingly, the BBC, as far as I know, never showed that boat, which is a great shame. But there it is in the Queen's Jubilee pageant on the Thames. There it is again, going past my boat on the Middlewich branch of the Shropshire Union Canal, in I think about 2007, but I'm not absolutely certain. And there's its engine, single cylinder steam engine, not unlike a single cylinder diesel engine when you look at it, except it's driven by steam. And I had a bit of trouble finding this out, but I think I'm right in saying that President is actually coal-fired. So that was one attempt to get engines into a boat. It worked, but somebody invented the diesel engine. And that is Rupert's boat. As it happens, it's a working boat from a long time ago. And the first engine that didn't go into this particular boat, but the first engine to come along that was a diesel engine to go into boats, was that thing, which was the Bowlinder single-cylinder semi-diesel. Some interesting features that engine's got. One big cylinder. You'll see on the top there's a blow lamp. So you have to get the hot bulb red hot before you try and turn the engine over. So you can't exactly turn the key and start it. It's got a very large flywheel at the bottom left-hand corner, where you pull a bar out and kick it over with your foot. And I'm told that the old boaters used to leave the doors open in the engine room in case they got thrown out, because it was better to go in the canal than be bashed into the side of the engine room. The other interesting feature of this engine, as I understand it, is that if you wanted to go into reverse, what you did is you stopped the engine and started it up in the opposite direction, which was not massively convenient. So they tended to get replaced by things like this, which is I think a 3-cylinder Gardner diesel, which is the sort of thing you will often see in traditional boats that are around the canal system today. Rupert's boat's actually got that engine in. That's obviously not in a narrowboat. That's a bit for a minute to find of it. And that is a Gardner single-cylinder semi-diesel, built, I'm told, by Rupert in Manchester. So that's the sort of thing which the old working boats used to have in them. So moving on, there's my boat. I told you we'd see them all before we finished. My boat, fairly modern, 2005, diesel driven, of course, fairly ubiquitous Isuzu 4-pot diesel. Very simple, 2-litre diesel producing 43 horsepower on a good day, I might say. So that's that is where we've got to. So that's how our boats have been driven up to now. But what do we do about the future? Well, let's say we can't use diesel, we can't use petrol, we can't use other forms of hydrocarbon. So what can we do about it? Well, there are a number of separate problems that we've got to address. The first problem is a new build boat. So if you were going to build a narrowboat today or next year, and you didn't want it to use hydrocarbons, how would you build it? That's a boat called Shine. It's actually an electric boat. It has a lot of PV cells on the top. I've not put that up particularly because that is the boat of the future, but that's what a boat of the future might look like. And certainly Shine, as far as I understand it, has a lot of the attributes that we would probably expect in the future narrowboat. We've got an existing fleet, boats like mine, boats like that. There are a lot of them, and they're going to be around a long time. We'll talk about that a bit more later, but they're not going to disappear very quickly. So we need to think about that. We're going to have 20 to 40,000 boats on the inland waterways in the future. However they're driven, they've got to be refueled and recharged. We've got an infrastructure that's based around red diesel at the moment. We're going to have to think about how the narrowboat of the future might be recharged or refueled. And finally, there are issues which we've not addressed a great deal at the moment, which we're calling non-propulsion issues. So there are other environmental issues associated with boats, which are going to need to be looked at. That's a picture of moorings, I think, on the Regent's Canal in London, and this is a particular problem in big cities. So those are the problems that we're going to look at. So let's look at new build, the future narrowboat. What might the future narrowboat look like? Well, first of all, it's going to have to be designed for flexibility because we all use our boats very differently. Some people cruise the canals on a continuous basis. They're cruising every day. They might be cruising 5 hours a day. They might be cruising 10 hours a day. Other people, like perhaps I was a few years ago, we take our boats out at the beginning of the summer, cruise them intimately around the system and put them in a marina for the winter. Other people take their boats out of a marina for a week or two's holiday, some long weekends. Other people, and I think I'm quite glad there's a lot of people like this, never take their boats out of the marinas. It's just as well, because otherwise it would be very, very crowded. So whatever we want in the future, it needs a certain amount of flexibility. It is almost certainly going to be powered by an electric motor. It's going to have a battery. And we think ultimately it will be equipped with a hydrogen tank and a hydrogen fuel cell. Now, hydrogen, well, we'll talk about hydrogen later, but that is what we are seeing as the future. I think that is a few years off, and we've got an intermediate offering to come along later, but that is where I think the future narrowboat is going to be. The battery is going to need charging. There's a number of ways we can do that. We can do it with a shore connection. We can do it with onboard PV cells, or we can use the fuel cell to charge the battery. Now, the interesting thing about all of the above is all the technologies exist. There's nothing that we are thinking of putting on the narrowboat of the future which doesn't exist in some form or another. And most of them are being developed for other fields of transport, mainly cars, small road vehicles. Now, the interesting thing about a narrowboat is that it is relatively low powered compared to most road cars. So most of the technology capacities are well within what we'd need for a narrowboat. On a narrowboat, weight is not an issue. Somebody wants to put a ton or more of batteries in a narrowboat, it's not a great big deal. And compared with a car, we all find our boats too small, I'm sure. Space is at a premium, but compared with a car, there's a fair amount of space on a narrowboat. There's also a fair amount of space to put PV cells as well. So in some ways, a narrowboat is a very, very good thing to develop a lot of these technologies. And we've said that hydrogen is maybe a little bit of a way off. Well, California has already got more than 10,000 hydrogen cars. And Japan, I believe, has got a similar number. So it's certainly not impossible. And what is more, it's been done before. In 2007, Birmingham University built a hydrogen-powered narrowboat called the Ross Barlow. There's a photograph of it. I think it's an ex-working boat. It's been converted. The interesting thing is that that boat used many of the technologies in a similar way to the way in which we would suggest using them today. The 2007 was, what, 13 years ago? All of these technologies have developed massively since 2007. But I think this boat led the way. And that is how this boat is driven. It has a store of hydrogen. In that case, it was a solid state store, whereas today we would probably use a high pressure cylinder. It has a fuel cell. Only 1 kilowatt, you note. You can certainly get bigger ones today. It has a battery. It has a motor. Obviously, it's got a propeller. It needs electricity to run the boat, lights, heating, whatever else they need. And it has the option of charging the battery through other means. So in many ways, it's similar to what we're talking about, but the technologies have all come on a long way since 2007. So let's look at what the things that we might be able to do today. Hybrids. Hybrids, as with cars, hybrids exist on the inland waterways. They can be put into a boat today. That is something that we tend to call a parallel hybrid. That is a bit like the hybrid systems that you might find in a car. It's available today. You can go to several engine manufacturers and get something that looks a lot like that. It is a 2-litre diesel engine, much as I've got in my boat. And you'll see on the back, there is a fairly large motor generator, which can be used either to drive the prop shaft through a belt, or it can be used to charge the battery up, obviously using the diesel engine to do that. And using that system, you can get a saving in fuel consumption, but it's still dependent, and always will be dependent, on a fairly large, or certainly a diesel engine, which uses hydrocarbons. So whilst that is available today, it is useful. We don't really see that as being the full solution to the problem. But that's the parallel hybrid. There is another option, which is the serial hybrid. So what's a serial hybrid? Well, let's just have a look at what constitutes a serial hybrid. You've got to start with a propeller, clearly. And that propeller, as we've said, is probably going to be driven by an electric motor. Now, one of the things I've discovered since I started doing this, guided by a lot of my colleagues, is that electric motor will actually drive a bigger propeller than a 2-litre diesel engine. It's got more torque. Why does that matter? Because a bigger propeller moving slowly is far more efficient than a small propeller moving quickly. So there's an immediate gain in energy saving because a motor can drive a more efficient propeller. We're going to need a battery. That particular battery is a car type lithium-ion battery. No reason why you can't use it, except they're fairly expensive. But on a narrowboat, it's perfectly practical, as we'll see later, to use lead acid batteries, or maybe one or two other things that are coming along. So we're going to need a battery. That battery is going to need charging. Well, there's one way of charging it. You can plug it in your marina to your shore power. Now, to be honest, for some people who just want to use their boat to go off for a day trip with the right specification, that could be enough. It wouldn't work for somebody who wants to cruise around the system for weeks on end, unless, of course, there's a lot of charging points around the system. I wonder if that's going to happen. You can charge the battery with PV cells. I think it's difficult to imagine, even with increasing technology, and certainly in a dull English day, that PV cells are ever going to provide enough power to drive the boat permanently. But they can make a useful contribution, we think. And obviously, as I've said before, a narrowboat's got quite a lot of area on which you could put a PV cell. So how in practice are we going to charge this battery? Well, you can put a marine generator in. That can be fairly small. It can be fairly efficient. And we'll look in a minute as to how this system stacks up against a 2-litre diesel engine. But that doesn't do away with diesel. It's probably a diesel generator, it might be a petrol one, but it doesn't do away with hydrocarbons. But if you've got that set up, if you've got a boat like that, it is relatively straightforward to do that. Take the generator out and put a hydrogen fuel cell in. So there is a boat that doesn't use any hydrocarbons, but it does use hydrogen. That might be a problem. We'll come to that a little bit later. So in a way, that is our picture of, or our vision of what the narrowboat of the future might look like. Now, apart from the fact it doesn't use hydrocarbons, why is that a better arrangement than, say, my 2-litre diesel engine? Well, it's quite a bit more efficient. And Malcolm, who owns a boat, hasn't got a hydrogen fuel cell in it, but he owns a boat that is in all other respects a lot like this. I'd be happy to answer questions as to why later, but we believe this setup has quite a few advantages. First of all, as I've already said, it can turn a large propeller, which is more efficient, and hence you can save quite a bit of fuel just doing that. The other thing is, it doesn't use any energy when idling. We've all done it, haven't we? We've come up to a lock, we've got to wait for somebody to come out of it, or maybe we're queuing up behind another boat. How many of us turn our diesel engine off? Perhaps we should, but we don't. We go into a lock, and while the lock's filling up, do we turn our diesel off? Probably not. An electric boat is not using any energy in those circumstances, because when the electric motor is turned off, it's not using any power. So that's a useful contributor to using less power, using less energy. If it hasn't got a hydrogen fuel cell and uses a generator, it can use a small generator at maximum efficiency. I've got a 2-litre diesel engine. Even at flat out, it generates 43 horsepower. We all know from our cars an engine of that type is capable of generating 150, 160, 180 horsepower. But I don't even use 43 horsepower most of the time on the canal. I probably use a third or a quarter of that. So my engine is not running at a very high level of efficiency. But a small generator, which can run, even if the boat isn't running, and charge the battery, can run at quite a high level of efficiency. And the result is that this setup is significantly better in terms of fuel consumption than conventional diesel, even if you haven't got a hydrogen fuel cell on the front. It also can make use of alternative charging options. It can be charged from the bank side if that's convenient. As we've already said, it can have PV cells, which can make a contribution. And the most important thing is it can be converted to hydrogen when that becomes sensible, practical, when the hydrogen becomes available. So that's the picture that we're seeing of the narrowboat of the future. So let's have a look at a boat which isn't quite there, but it's pretty close. This is Ampere. It's Malcolm Bridge's boat. It is a fairly conventional narrowboat. I think, as Malcolm will tell you, it's actually quite a heavy narrowboat. It's not a lightweight. It's heavier than my boat. It's, I think, about 57 to 60 feet long. It's certainly very typical of many of the boats that we all use. How does it perform? Well, these are figures from Malcolm, and I'm sure he'll be more than happy to justify them later. He reckons he usually uses about 3 horsepower on that boat. And part of the reason for that is because he's got a fairly large propeller. Now, some of us might like to cruise a bit faster than that, but Malcolm says that's fine. He can get along at those sort of speeds. The canal's in good nick. And his generator charges at about 80, 85 amps, which means to replace an average hour's cruising, it takes him 20 to 25 minutes of generator time. Now, the generator uses just under 1.5 litres an hour. So per cruising hour, he's using between 0.5 and 0.62 litres per cruising hour, whereas a conventional 2-litre diesel would probably use between 1.5 and 1.8. And I can certainly tell you that my boat uses about that. It uses about 1.5 litres an hour on the canal and about 1.8 if I'm on a river. So even if you're using diesel, this type of arrangement gives you a much better performance than the sort of boat I've got. There's a bit more information about Ampere. Big propeller, quite a bit bigger than I think most narrowboats have today. There are issues with that, but it does work. There's the generator, and that generator can, as our normal diesels do, provide domestic hot water, and in Malcolm's case, it also provides underfloor heating. So that sits in a bow locker, fairly small, quite a bit smaller than my 2-litre diesel engine. He runs it on lead acid batteries, 1.7 tons of them. If you've got some money, you could replace that with a lithium-ion battery, and it might have other advantages in terms of the speed at which you can charge it up and the way in which you can charge it up. But it runs quite happily on a fairly big bank of lead acid batteries. And there's his motor. A fairly sophisticated motor compared with the sort of thing that you would have found in Ross Barlow in 2007. But that all helps to add to the efficiency of what we're trying to do. So let's think a bit more about hydrogen, because a lot of people say, hydrogen, when's that going to happen? Well, let's have a look at the development of hydrogen outside the canal system. March 2020, Hyundai said they were going to produce a hydrogen-powered excavator. There's a hydrogen-powered boat in Bristol Harbour. It's a ferry boat. It can be done, even with a boat. There's a hydrogen bus, which is coming on the streets of London in the near future. And there's a Cummins truck in America. They've converted a truck to hydrogen. It's a bit difficult to imagine how a vehicle like that is going to run on batteries. So they've got to find another way of doing it. Although I happen to know that Cummins in Darlington are looking at battery-powered commercial vehicles. So it might be possible, but they've produced a hydrogen-powered truck and it works. And there's a hydrogen-powered train, which Alstom are hoping to get on the British railway system in the next year or two. And I happen to know that Birmingham University are also developing a hydrogen-powered train. So hydrogen can happen. Now, everybody says hydrogen, that's dodgy, isn't it? You know, hydrogen explodes. Well, actually, so does petrol. I'm an engineer. I'm fairly confident that you can engineer a hydrogen system to be at least as safe as a petrol system. It will never be as intrinsically safe as diesel, because diesel is relatively safe to have around, but it will be as safe as petrol, I think. And hydrogen engineering is well understood. The chemical industry has been handling hydrogen, high pressure, low pressure, in all sorts of ways for many years. People say, well, you better put a hydrogen-powered boat into a tunnel. Well, I think this train is going to go into a tunnel, so you probably can. And anyway, with the sort of boat we have in mind, you can imagine a circumstance where when you put your tunnel light on, it's sealed off the hydrogen bottle you ran through on your battery. There's all sorts of ways around it. So hydrogen can be made to work. There are problems, and we'll come to them. Other things are being developed which might help us along in our search for a vision for boats. Oh, sorry, I forgot that one. There's a hydrogen-powered forklift truck for you. So there's plenty of it around. Another development, which is probably not as advanced as a hydrogen fuel cell, is solid oxide fuel cells. These are a different type of fuel cell. As you see at the bottom left-hand corner, Nissan have produced a car using one. The interesting about them is they can run on hydrocarbons or they can run on hydrogen. So if you could put one of these into a car or an aeroboat, you could use it with hydrocarbons today, which typically would be a hydrogen carbon gas like propane or methane. But if hydrogen became available, you could run it on hydrogen. So there's a way in which we might be able to find a halfway house. Battery technology is developing rapidly, but there are things around now called supercapacitors. And there is a thought amongst some people, mainly those that are selling them, that these might replace batteries. You can charge them much faster, they last a lot longer, and in many ways they're safer than batteries, particularly lithium-ion batteries. They're much larger than the equivalent battery is, and they're quite expensive. The size probably wouldn't matter for a narrowboat, the cost probably would. Bottom right-hand corner, you see that Tesla have just bought a company that makes supercapacitors, so they must think there's a possibility. And batteries are getting better as well. GM have just announced a battery they reckon will last for 1 million miles and have a 600-mile range. Don't know how far off that is, but it's certainly possible. So batteries are becoming quicker to charge. They're becoming giving a longer range. That might influence what our future narrowboat looks like. I mentioned that Ross Barlow stores hydrogen in a solid framework. Those have developed a lot since 2007, and this was announced on the BBC in 2020, the latest metal organic framework, which will hold large amounts of hydrogen. Advantage of this system is the hydrogen is at a much lower pressure than a hydrogen tank, which cars use at the moment, which typically are around about 700 bar. So that is developing. That might make it easier to put hydrogen on canal boats and into cars. We'll have to wait and see. And of course, PV cells are developing. PV cells today are more efficient than they were 5 years ago and 10 years ago. And we're getting up to nearly 50% efficiency now with PV cells in theory. Again, I don't honestly think these will ever be the full solution to powering a boat, but I think they can make a useful contribution. So there's our vision for how the narrowboat of the future might be built if you're going to build a new one. But most of us have got boats, and some of us are probably not going to buy another one. So we need to think about the existing fleet. Now, this is a terrible generalization, but the existing fleet comes mainly in two flavors. One is a boat like mine, which is a fairly ubiquitous 2-litre diesel engine, modern 2-litre diesel engine in a relatively modern boat. And the other flavor of the existing fleet is a boat like Rupert's, which is an old working boat, which has been lovingly restored, probably has a fairly old engine in it, and probably has different problems, different ideas. So what are we going to do about the existing fleet? Well, first of all, it's going to be with us for a long time. A narrowboat, as many people listening will know, lasts a great deal of time. I can't quite remember when Rupert's rope was built, but it was long before I was born. My boat was built in 2005. It's hardly running. There's another 30 years life in my boat, and that's if you don't look after it. So that fleet is not going to disappear overnight. Cars, how long do they last? Probably averaging 10 to 12 years. The boat fleet lasts a lot longer than that. So what can we do about it? Well, we can all learn to use less fuel. I think that's an important thing, but that's only going to make a small contribution to what we're doing. So can we use biodiesel in these boats? I think possibly we can. Biodiesel goes into road fuel or road diesel at the moment in a percentage of about 7 to 10%. If we're going to solve the problem for the inland waterways, we'd probably want to use 100% biodiesel. Now, why don't we use 100% biodiesel on the roads? Well, biodiesel's got one or two problems if you use it 100%. First of all, some engines need some minor modifications to use it because biodiesel does eat away at seals, mainly in the fuel system, on some of the older engines. Modern engines like mine are probably biodiesel proof, so I could probably use 100% biodiesel in mine without getting that problem. Some of the older engines, you might need to do some conversion work, but it's not massively expensive. It is reasonably practical. Slow burn. Biodiesel burns slowly compared with mineral diesel. So if you were to run your sort of 2-litre Mercedes road car on 100% biodiesel, because it burns slowly, that engine will probably struggle because it's got a turbocharger and it probably revs up to about 4,500, 5,000 RPM. Even my engine, which is a modern engine, let alone something like Rupert's, probably revs no greater most of the time than 1,200 RPM. So a slow burning fuel is probably going to be okay. Biodiesel doesn't perform terribly well, 100% biodiesel we're talking about here, when the temperature gets low, as it will tend to in an English winter. It does depend on, biodiesel is made from vegetable oils. It can be made from almost any vegetable oil. And depending on what you make it from, its low temperature performance varies. So if you make it from rapeseed oil, it's pretty much okay. If you make it from palm oil, which most biodiesel is made from, you get temperatures down around 5–10 degrees. It tends to go a bit claggy. And if you've ever put, anyone's ever put olive oil into the fridge, you'll see what happens. It goes a bit gooey. So that's a problem, particularly if you've got 100% biodiesel sitting in your tank in the marina over a typical English winter. Biodiesel also absorbs more water than conventional diesel. I mean, conventional diesel, as we all know, can absorb water. We all take precautions in the winter to try and limit that. Biodiesel is worse than that, so that will need addressing. But the biggest issue for me is sustainability. Biodiesel, as I said, is made from vegetable oils. Most of the vegetable oils that biodiesel are made from are in fact foodstuff oils. Even if they're not foodstuff oils, they've got to be grown on land which could probably be used for growing foodstuffs. So that is why we don't see biodiesel as the ultimate solution for all road vehicles, because it would have a massive effect on the world's food supply if we tried to use the amount of biodiesel that we use with mineral diesel. So there is a big question mark around the sustainability of biodiesel in large quantities. Having said that, looking at it slightly selfishly, the inland waterways does use a relatively small amount of diesel, probably around about 5,000 tonnes a year, which sounds a lot, but it's not in the big picture. So maybe you could justify running the inland waterways fleet on biodiesel without seriously affecting the world's food supply. It needs looking at. Improved biodiesels are being developed, and we have identified a biodiesel which claims to address all the problems I've listed above. We have been offered some to try out, and one of my colleagues is planning to do that when he gets out of lockdown, but we haven't had a chance to do it yet. But there are biodiesels now being developed which can solve a lot of those problems. So that might be a way forward for the existing fleet. Right, now let's go and say, right, we've now got a load of canal boats running on biodiesel. We've also got a load of canal boats that are either want their batteries charging up or they want to be filled up with hydrogen. So how do we recharge and refuel them? And to be honest, I think this is the biggest problem we've got. Nothing I've said up to now requires massive technology changes or technology advances. But putting an infrastructure in place which can recharge and refuel the narrowboat in the future is going to be quite a challenge. Not so much so for the existing fleet, because biodiesel can use the existing infrastructure, sort of thing we all see in our marinas and boatyards and hire fleet bases. Maybe we'll have a few problems with seals on 100% biodiesel, but again, that's overcomable at a reasonably modest cost. Electrical recharging. Well, if you're the sort of person, which I'm afraid regrettably I am at the moment, who uses my boat for the odd weekend and the odd day trip, leaves it in the marina most of the time, plugging it into a normal marina 16 amp charging point is probably good enough. If I wanted fast recharging, my marina would have to put in a lot more infrastructure. Can we see bankside charging stations, much as you see the Tesla stations on the motorway? Well, I'm not sure that I can foresee a time when every visitor mooring on the inland waterways is going to have a charging station on it. Maybe it will, but I think that's a bit of an issue. And obviously, with any battery-powered system at the moment, like cars, charging time is quite lengthy and the range is a bit limited, just like a car. So that's problems that would have to be overcome if we went purely for a battery-powered boat. Hydrogen. If we could go hydrogen, yes, you can have a hydrogen refilling station beside the canal or in a marina or in a hire boat base. It will be more expensive than the equivalent red diesel pump, but the technology exists, it can be done. You can refuel a hydrogen boat in roughly the same time as it takes to refuel a diesel boat. You can have a tank big enough or a pressure vessel big enough to give you an acceptable range, much as you might have on your diesel boat today, but it does require a significant distribution infrastructure. I'd have to say at the moment also that hydrogen is quite expensive. It's much more expensive than, say, red diesel. But I think that's a problem which the world has got to solve, because I think hydrogen is likely to play a big part in our future transport policy. But we still need a distribution infrastructure, as we do for electrical recharging. And the problem we've got there is summed up by that. If no one is going to invest money in putting the infrastructure in until there are boats around that can use it, no one's going to buy a hydrogen-powered boat or a battery-powered boat unless there's an infrastructure in place to allow it to be recharged or refueled. The classic chicken and egg situation. So that's why we say that the barrowboat of the future will have to be flexible. It will have to have a degree of flexibility built into it. And probably the intermediate step is to start with a small diesel generator and perhaps the ability to convert to hydrogen at a later date. So I'm not sure we have a solution to that. If we could persuade most of the hire fleets to convert to hydrogen and refuel their boats every week from their hydrogen tank, then perhaps I might be prepared to buy a hydrogen boat if I wasn't too far from a hire fleet base. But I put that out there for people to think about. So that's the three top problems for propulsion. There are a few non-propulsion issues, and in all honesty, we haven't addressed those to any great extent, but we need to think about them. There are behavioural issues associated with cruising, and we've all done it. We all do it. Running engines where we don't need to do it. Maybe not going as fast as perhaps we do. All that would save some fuel. It would have an environmental benefit, but it wouldn't do away with diesel. Most of our boats use hydrocarbons or solid fuels or both for domestic purposes, heating, cooking, hot water, those sort of things. So there's an issue that needs to be thought about. And there are environmental issues associated with boats being used primarily as domestic accommodation. And those people who live in large cities, particularly London, where boats are being used extensively because they're a cheap form of accommodation and have to run their engines to charge their batteries or have to use stoves to keep the boat warm in the winter, there's quite a lot of environmental issues associated with that as well. So those are other problems which I must admit we haven't addressed to any great extent, but they need taking forward. So that's our vision for environmentally friendly boating. It is a vision. It is not a solution, but hopefully what it will do is allow other people to come up with ideas that might lead to a solution. And I put this up because the first time I did this talk, or a shorter version of it, it was to people who knew nothing about waterways. But I thought it was worth just looking at this because I've been a member of the IWA for quite a lot of years. I'm proud to be a member because the IWA saved the British Waterways Network that I am passionate about. And I think if we're going to save the network again, we've got to find a way of getting boats around the network without using hydrocarbons. So I think there is an opportunity for the IWA to do it again, to save the British Waterways Network. So thanks very much for listening. I'm very happy to answer questions, and I'm sure Malcolm and Rupert will be as well. So I'll hand back to Paul to see if anybody would like to answer some questions.
Bowman, thank you very, very much indeed. That's a really good tour around the whole concept of sustainable boating and alternative propulsion. So thank you for that. And we have had a lot of questions coming through. So delighted to welcome Malcolm and Rupert to answer some of the questions. And I know they'll have been looking at the questions as we've been going through. Malcolm, maybe if I just kick off with one, and while I'm just asking this question, I would encourage everyone, if you've got some questions, do please click on the question and answer button at the bottom of your screen and type in your question. I'm conscious that we've only got about 10 minutes, so we'll try and rattle through as many.
Sorry, I've talked too long.
No, it's absolutely fascinating, and I'm sure we can do a follow-up on this again. But I'm really just interested in that chicken and egg thing. What is going to be the main driver? We've had questions through that have touched on the red diesel, fuel duty relief. We've had questions of cost. You've made a really good case in terms of efficiency of fuel use. But you know, what's going to be the initial driver? What do you think will tip the balance? I'm happy for any of the other Malcolm or Rupert to come in on this as well, but first for you.
I mean, I think the infrastructure issue for recharging or refueling is the biggest problem. The rest, the technologies exist. There's some cost issues with them, but they exist. We can do things, and Malcolm can talk about it better than me, to dramatically reduce the amount of diesel we use. But if we want to move away from diesel, we've got to solve this problem of some sort of an infrastructure in the waterways, be it electrical, be it hydrogen, be it both. Malcolm, have you got anything you'd like to add to that?
Yeah, I think I could probably talk all night on this, but wouldn't be very popular if I did. I think there are sort of two sides to this. The first one is that there are a lot of people who would like to take up electric boating. The number of people who've looked at our boat over the last 5 years and said how wonderful, and then said, "Ooh, can't afford that," it is legion. So at the minute we have a cost issue, and if we can reduce the cost of the sort of system that we've got until it becomes comparable with a diesel system, then I think you would see quite a lot of people wanting to move to that first stage down the road fairly quickly. I have some ideas about that, mostly around generators and batteries, where I think there are much cheaper options than the ones traditionally offered into the
Malcolm,
boating.
you've gone quiet.
Oh, sorry.
I can still hear you, Mel.
Well, I'll pick that up till Malcolm comes back. Yeah, I mean, I think where Malcolm would be is if you could produce an electric boat, if an electric boat became affordable, then people would build electric boats. They might put a diesel generator on the front, as Malcolm's got. Sorry, Malcolm, I think you're back now. You disappeared briefly, yeah. And then you could move to, as an electric recharging system became available, you could move away from your generator to an electrical recharging system. And maybe you could put a hydrogen fuel cell in. Is that where you're thinking to go, Malcolm?
My view is that the critical intermediate stage is going to be the one that you skipped over fairly quickly, which is the solid oxide cell. They are currently in quite sizable production, largely on the continent, where they're used in combined heat and power systems for domestic properties. But a very small fuel cell, we're talking here about maybe a kilowatt, is probably sufficient to power a 50, 60-foot boat. It's more efficient than a generator, and because it can be run 24 hours a day, your battery bank can also be reduced. And I think at the point we can identify something suitable there, we've probably got a system that's going to be cost competitive with diesel, and we'll see a rapid movement. And once you've got that, all you then need is to change your gas tank for a hydrogen tank, and you've got your hydrogen boat when the hydrogen becomes available.
Yeah.
Okay. Well,
I think the point really is that the serial hybrid we've described has got a lot of flexibility in it. You can have various versions of it that can use various things, and you can swap things around. I mean, if you took my boat, to try and put a electric hydrogen drive into my boat would be a massive task. To put it into Malcolm's boat would be a much lesser task.
So we've just had a comment through from Tim Knox on Shine. He's just saying that like us to know that he's averaging 9 kilowatt hours on his PVs a day at the moment. Now, of course, it's been we've been lucky with pretty good weather over the past few weeks, but that's pretty impressive.
Yep.
So conscious of time, we've probably only got about 5 or 6 minutes left. Just going to again. One of the points you raised, Bowman, is that being able to refuel is an issue. So we had someone hiring an electric narrowboat in the Molenbeek last year. Absolutely wonderful experience, quiet and all the rest of it. But the infrastructure, charging stations, there's none except really on the Molenbeek. How are we going to get around that in the near future?
Well, the only solution is money, isn't it? I mean, the Molenbeek is obviously an isolated canal, and it's an ideal place to do that, which is presumably why those boats have been available for some years on the Molenbeek, because basically, unfortunately, you can only go up and down the Molenbeek. So you put a handful of charging stations in, and for your holiday, that's absolutely fine. We've got 2,500, 3,000 miles of interconnected waterways in the rest of the system. to imagine that all of those are going to be provided with electrical charging points in the near future is quite an ask, I think, which is why we set out by saying whatever you see as the narrowboat of the future, there's got to be some flexibility in there. There will be times when you can plug it overnight and charge your battery up. You might come out of a marina where you've been for a week and you charge your battery up. But I don't think you can absolutely guarantee that if you're going to cruise around the system for a month, you'll be able to find a charging point every time you need it. So you needed the added flexibility of a fuel cell, a diesel generator. I think Shine, for example, does also have a diesel generator, if I'm right. And you need that additional flexibility.
Yeah. Rupert, any thoughts from you on that?
Not really. I looked at one of the questions from Roger Still about the urban areas, the infrastructure, what it would look like, and how it would be defined. I think it just needs to be defined as a source of mains electrical power. It just needs to be a power source. It doesn't need to be a defined charging network like a car charging network.
Yeah, I think that's a really important point, that we can, if we can plan this in to restorations or plan it into infrastructure change near the waterways, then we've got the chance to build some of this in. And there was a comment regarding, sorry, Malcolm, you wanted to come in?
Yeah, just a very quickie. Bowman briefly mentioned this battery development that General Motors is claiming. If that were to come to fruition, and if it were to become available for boats, that would give the potential for something like 10 days cruising using batteries within the space that we've got in Ampere. That would make a huge difference to the viability of bankside charging.
Yes, it would.
So Malcolm, you also, sorry, Bowman, you also mentioned that obviously we're likely to see the existing fleet around for some time. And you did touch there being a small possibility, if you like, of retrofitting the current modern fleet to electric motor propulsion. There's a comment from Graham Russell about, of course, you may well have a larger prop. Is that going to give problems in terms of the drafts and the ability to take a boat with a larger prop, or particularly a traditional or a current fleet boat that was retrofitted and needing a larger prop? Is that going to be possible? And that's, I think, really one for you, Rupert.
It's certainly one for Malcolm as well, I think. But
I agree. Having since I own a boat with a large propeller, it is quite noticeable. I've always considered that large propellers are more efficient, but you can have a shallower boat with a dropped skeg, i.e. the skeg is lower than the bottom of the boat, and that does work. It needs to be fed in properly, so that it's not going to catch on things like sills of locks and things like that. But it does work because generally the canals are saucer shaped. So you're going along the middle of the canal. So the skeg will be in the mud, but what it does is it drops the prop shaft down within the profile of the boat and gives you room for a larger propeller.
Well, Malcolm, you have some experience of this, so what are your thoughts?
I would have to admit that the 30-inch draft that we chose for Ampere, which to a fair extent was chosen for aesthetic reasons, but it's allowed us to put that 20-inch prop on very comfortably. That is too much for comfortable cruising on our current waterways. But that is fundamentally down to a lack of dredging. It's the canal that's wrong, not the boat, if you see what I mean. But what Rupert was saying about a dropped skeg is right. I mean, if you were to take a boat with a 24-inch draft and a dropped skeg to give you about another couple of inches, you get the 20-inch prop that we've got in quite comfortably. And I don't think you have too many cruising problems.
But I think the point that I think the question was asking is, how practical will this be on an existing boat? I think it would be more difficult on an existing boat though Rupert or Malcolm might or might not agree. I think the problem I see with existing boats is that most owners, and I would have to put myself in that category, would probably not be prepared to put the money in that would be required to convert them to electric drive.
Yeah.
Because regrettably, well, not regrettably, I think that's quite a good thing. Most narrowboat owners don't go out very often. The number, I don't know what, I haven't got a modern number, but I once read that the average number of engine hours on a British leisure boat was 20 a year. You know,
Right.
it's not going to be worth investing, you know, large numbers of thousands of pounds to convert a boat like that to electric.
So I'm going to bring Rupert in there.
I think that if you've got an old boat that you're thinking of putting a new engine or converting to electric, 10 to 1, the stern gland will be badly worn enough that it needs to be replaced as part of the job, and taking out an existing stern gland and fitting a new one slightly lower down within the boat is a fairly trivial task for a boatyard. And to alter the skeg on a boat, that wouldn't be a problem, and it wouldn't
planning
be
it in. So planning it into that sort of slightly more major maintenance or upgrade of a boat might be a possibility. Malcolm.
If I can come back briefly on Bowman's point about most boats doing very little cruising, to be honest, they don't matter. It's those of us who spend 200 days in
fair
cruising.
So
fair point.
I'm really conscious of time, and we have got so many questions. I hope we'll manage to capture these questions, because there's questions about boats made of composites, commercial activities, hydrogen-based internal combustion engines. So many questions. I think I hope we'll be able to put a paper. I know that this group has prepared a paper, and I think it should be widely circulated. I also think we should grab the questions from tonight and try to answer those as a quick Q&A at the end of the paper that we circulate. But I think for now, just given time, just keen to give each of the three other contributors a chance just to say a very brief final remark. Rupert, first with you, and then I'll go to Malcolm and then to Bowman. Any thoughts about the future of sustainable and alternative propulsion? Just to close.
I think it's very important. I think what Bowman said is generally correct, but with an eye on another question that's been asked, I think it's important to preserve the heritage of the canal system at the same time. And I think there will always be a place for the historic narrowboats chuntering around in the same way as they did, as a preserved item, but not as, but it's the large, the mainstream narrowboats that I think we need to look at in terms of changing.
Great, thank you. Malcolm?
I absolutely agree with what Rupert's just said. The canals would not be the canals without boats like his around. My point is that I think the key to everything is cost.
Yeah,
we need to get that down.
Yeah, I guess it's really making that ultimately the business case might be a hard-nosed way of looking at things, but there is that commercial reality. And with what we're facing today, there's an even bigger commercial reality to the boating world. Bowman, final words to you.
Well, I can't disagree with what Rupert said and what Malcolm said. I suppose the only thing I would add is, what's the important thing here is, for me at any rate, is to preserve the canal network. And in the long term, unless we find a way of doing it probably without using hydrocarbons, we ain't going to do it. So that, I mean, I absolutely agree. Rupert's boat's a lovely boat, and I wouldn't like to see a network without those on it. But if we want to keep the canal network, we're going to have to find another way, aren't we?
I think we are. And to echo your final slide, the Inland Waterways Association did a lot and has done a lot and is still doing a lot 75 years on. And in my view, the association that was set up to campaign for the regeneration of the waterways needs to be constantly looking at future uses and future risks to the waterways and responding to it. And I'm delighted that we've got this group in place in the Inland Waterways Association, because I think we're just at the very beginning of this issue. And I thank you for your work and the rest of the group's work on this. And I'm sure we'll see you back on a waterway webinar very soon, talking about the next stage. So thank you, Bowman. Thank you, Malcolm. Thank you, Rupert. Thank you, everyone, for joining us tonight. I'm sorry we haven't got to all the questions, but we'll find a way of getting those answers to you and shared more widely in future. So thank you for joining us tonight, and I hope you'll be able to join us on another waterway webinar very soon.